All right, guys, we're going to go ahead and start talking about energy. And what I want to point out here is that if we define energy, a great and easy way to kind of describe that is the ability to do work. Now, I'm going to go ahead and say this, but for us, work, we have our own definition for that we use in daily speech. But in science, work is essentially defined where we have some kind of a mass that we are able to move over a distance. And that is through an application of force. So if you can apply a force to move something over a distance, then that is considered to be work in physics. Three important definitions to know. First of all, we have the definition of energy, and we have the definition of potential energy and kinetic energy. So if we were to examine pretty much what we're talking about here, this kind of goes back to a lab you did in class where you had an object. Now this object that I'm looking at, let's say it's a stone or a rock, has a mass of 1 kilogram. That mass is above the ground at a height of 1 meter. So we have a formula we can use to calculate that, where we can say that gravitational potential energy is equivalent to mass times gravity times height. Just so you know, that mass should be measured in kilograms, height should always be measured in meters, and gravity on Earth is close to 10 meters per second squared. And that means as something is falling, it's going to speed up and get faster and faster until it reaches something called terminal velocity. Now, one thing we can tell you is if in this situation, if you had the rock above the ground and you let go of it, its potential energy will become kinetic energy, the energy of moving objects. So the kinetic energy formula is 1/2 mass velocity squared. So to solve this, you're going to multiply 0.5 times the mass times velocity times velocity. You're multiplying 4 numbers together here to get that answer. Whether you're calculating potential energy or kinetic energy, you are always going to express your energy in a unit called joules. And 1 joule is equivalent to 1 kilogram accelerated 1 meter per second squared. Okay, all right, let's go forward. Here we have some other kinds of energy. We have sound, electrical, chemical, nuclear, and thermal. Big idea here. You can go ahead and pause the video to make sure you understand all of those definitions. But the big idea here is that energy can go through what we call a transformation. And that is where you have one kind of energy becoming a different. So if I were to, and this is something I showed you in class, but if I have one of the glow sticks, those little chemical glow sticks that you can buy around Halloween time, they're pretty popular. They look kind of like this. My art is not wonderful, but it look kind of like this. And you bend them in half, you hear like a snapping noise, and then what happens is they begin to radiate light. Okay, so in that situation, what we have is we have a type of chemical energy that is becoming what we call radiant energy. It's giving off light. So a transformation is essentially where one kind of energy becomes another kind of energy. And it's very normal. It happens all the time. All right, we're going to look at some calculations here. We have a 6 kilogram object traveling at 2 meters per second, and we have the potential energy of the 6 kilogram object at 2 meters above the ground. So let's go ahead and do the easy one first. I think calculating gravitational potential energy is easy. So I'm going to go ahead and just write the formula. And then I'm going to rewrite the formula, but this time instead of the variables, I'm going to put in the numbers. So for this one, I know that my mass is 6 kilograms. Gravity is always going to be 10 meters per second squared. And then my height, it says, is 2 meters. So this one's actually quite easy. I can do this in my head. I don't need a calculator at all. So 6 times 10 is 60. 60 times 2 is 120. And remember, we express energy in joules. Now looking over the other side, this one's going to be a little more complex. But kinetic energy is 1/2 mass velocity squared. So I'm going to say kinetic energy is equivalent to 0.5 times the mass, which is 6, times 2. And remember that my velocity is squared, so I have to have it in there twice. All right, not squared, sorry. My velocity is squared, but I don't need to put meters per second squared because that's what we have for acceleration. So here I have to multiply 4 numbers together. 0.5, so that's 1/2 mass velocity. All right, so just do the math real quick. And again, this one's also pretty simple. You can do this in your head. 0.5 times 6 is going to be 3. And then 2 times 2 is 4. So 3 times 4 is 12 joules for my answer here for this question. There's a little video here you can watch in the presentation, and I suggest that you do. But when does a coaster have the highest energy? When does it have the lowest potential energy? So lowest potential energy is going to be when it's at the lowest elevation, because remember that height is part of that. Okay, the highest energy, that one's a little complicated, but the truth is it's going to be right here at the very beginning. It has the highest potential energy. So even though as it rolls down the hill, the potential energy is going to become kinetic energy. And then as it goes back up the hill, its kinetic energy is going to become gravitational potential energy as it goes back up here. And so it's transforming from one kind of energy to another. But the thing to know here, and this is part of what you should understand, is that anytime there is an energy transformation, some energy is lost. And it is not destroyed, because we know from the law of conservation of energy that energy cannot be destroyed. It is lost because of friction. It becomes thermal energy. So anytime you have energy going from one form to another, part of your energy becomes thermal energy. And honestly, if you were to, like let's say this was a roller coaster, if you were to touch the wheels of the roller coaster before and after, the wheels would actually feel very hot at the end of the roller coaster's voyage. Elastic potential energy, this is like the energy that you're going to have, like let's say you had a rubber band and you pull it back and you stretch it out. That is elastic potential energy, and it works pretty much like the same way as gravitational potential. The formula for this is actually complicated. We do not address that in class, but I just want you to know that this is something that exists, and it's another form of potential. What happens to kinetic energy if you increase mass or velocity? So remember that the variables are mass and velocity. Anytime you increase one of these, either one of those, you're also going to increase kinetic energy. Now, on the flip side of that, anytime you were to decrease one of these, either of those, you would also decrease kinetic energy. Understand that this is something that you can show in a graph right here. We call that a positive correlation because as you increase one of the variables, the other one increases. So the kinetic energy, you can say that's the responding variable, and the mass and velocity are independent. So if you increase one of these values, as a result, you're going to increase the kinetic energy. If you throw a baseball faster, it will have more energy. If you throw a heavier ball, like a softball, it's going at the same speed, it's going to have more energy. And so just understand that if you increase mass or velocity, you increase those. Additionally, same thing is true with gravitational potential energy. It is mass, gravity, height. So if you increase the mass, if you increase the height, or if you were able to go to a different planet so you can increase the gravity, increasing any of those variables will also result in an increase in energy. One thing I want to remind you of is that all energy is measured in a unit we call joules, and we use a capital J to. In this scenario, at the very top, in step 1, we have gravitational potential energy. Step 2, we have the GPE becoming KE. Step 3, you have kinetic energy only. Step 4, the kinetic energy is becoming gravitational potential energy as it goes up to the very top. In step 5, you're going to have both, but basically you're going to have more of that gravitational potential energy as this box is going to probably slow down almost to a complete stop. Now understand that as you go down this list, what's happening is your total energy is remaining the same, but the amount of gravitational potential and kinetic energy is decreasing, because one thing that's happening every time you go, and you see these little arrows, every time you go from one energy form to another, you have thermal energy that is produced. And again, like I said, if you touch the bottom of this little box, it's going to be warmer than it was before you started, because every time you have an energy transformation, part of that energy that you're transforming becomes thermal energy. Again, the potential energy formula is mass, gravity, height. Another one, now here's the thing. If I multiply mass times gravity, that's going to give me weight. So another formula you can have for GPE, so we always use mass, gravity, height. You could also have weight, height. Now in that, if you have that formula, understand that in physics, weight is measured in a unit called newtons. Okay, that's not something you're familiar with, but that's how we express weight in physics class or in science class. We don't use pounds, and we certainly do not use kilograms, because kilograms measures mass. The kinetic energy formula, again, we're presenting that for you guys. Let me just go ahead and do a quick problem here. Let's say, I'm going to make this up. Let's say we have a 6 kilogram bowling ball, and we are throwing that at, let's have it, let's say we put it into a massive catapult and we throw it across the field at 5 meters per second. That's pretty fast. So let's go ahead and let's solve for this. Okay, so we're going to write our formula. Okay, and now let's replace those variables, right? So we know that kinetic energy is going to be 0.5. That's same. So I use 0.5 instead of 1/2, but if you want to use 1/2, that's fine. Times 6 times 5 times 5. Okay, so what I'm doing here is I'm putting my velocity twice because it's velocity squared. I'm putting my mass just right below there. And then my 1/2, I change that to 0.5 to make it something that's easier to solve. Now, before I go further, I need to make something very clear here. You cannot solve this formula unless you're using what we call SI units. And all of those SI units, these are the standard units that you have to use when using these formulas. Otherwise, your calculation will be wrong. Let's just kind of get into it. As I just said a couple of slides ago, the standard unit for weight is newtons. For mass, it's always going to be kilograms. So if I give you a problem and it has grams, you need to change those to kilograms. Like I could do that. Like instead of saying 6 kilograms, if I wanted to, I could say 6,000 grams. And that's, something that you could that was something that I gave you. All right, let me kind of go. Oops, can't go back. All right, let's just. But anyway, let's just kind of rewrite it over here. So um, I said 6 kilograms at um, 5 meters per second. So let's just go ahead and solve it. Okay, so half of 6 is 3, and then 5 times 5 is 25. So 3 times 25 is going to be 75 joules. So you should have 75 joules for your answer for that problem. Now, kind of going back to what we talked about before, though, all of your SI units. Again, we have mass is kilograms, weight is newtons. For any kind of distance, you want to make sure that, like we measure height, you want to make sure that you're using meters for that. So if I give it to you in kilometers or centimeters, convert to meters. Additionally, velocity should be in meters per second. And acceleration is a little complicated, but that should be meters per second squared. And we'll talk more about that in the future. Now let's go ahead and look at this question. I'm trying to go fast for sake of time here, guys. What do you think energy means? Think about someone saying something you have a lot of energy. Someone saying you have a lot of energy. What does that mean? So energy is the ability to do work. If someone says you have a lot of energy, then that's probably going to mean you have a lot of movement. So remember that kinetic energy is the energy of movement. Movement energy. And before that, where does that energy come from? So if you have all that kinetic energy and you're jumping around, moving around, that kinetic energy is going to come from the food that you eat. And that's going to come from chemical energy, which creates some potential energy, right? So this is like something I like to say this is stored energy. But we can also say energy of position. Another way to think about potential energy is, and this is just going to kind of help you to understand energy in general, but another way to think of energy is to say, potential energy is to say this is energy that could become a different kind of energy. That's how I like to think of it, and that works for me, and that's what I want to encourage you guys to do, and that will help you on the quiz. Just think that potential energy is energy that can become another kind of energy. Let's go ahead and let's match these, and I will tell you this is a great slide because this really gets to the heart of a lot of our content here, okay? So let's go ahead and let's just kind of go through the list here. Chemical is going to be F, and this is going to be all the chemicals stored in the bonds of molecules. So if you have a CO2 molecule or an H2O molecule, let's just kind of sketch it real quick. If I can release these bonds, then I can get a lot of energy. Okay, I can release it. I can have it kind of flow out. Want to go ahead and go back to the light stick we just had, right? That I used in class. So radiant energy is going to be the energy of light. So we had in that glow stick, we had the chemical energy when we snapped it. It was releasing some chemical bonds, and so those chemical bonds became the radiant energy. So the chemical transformed into radiant. We'll go ahead and just keep talking about atoms here. We have energy locked in the nucleus of an atom. The word nuclear looks like the word nucleus, and so that's how we got that name for that kind of energy. Basically, if you pop an atom open and you release the nucleus, the energy in the nucleus, you can have a great amount of power that is unleashed. Electrical energy is going to be A. It comes from the word electrons or electric charges. Let's see here. Let's go with the next one, B. Energy from vibrations of matter. That is sound energy. Anytime you pluck a guitar string, you'll notice a guitar string is vibrating. When you speak, when you sing, your vocal cords are creating a vibration, so all sound is produced by vibrations. This one right here is going to be E. Thermal energy is the energy of heat. And lastly, we have C. That'll go right here. The energy of motion or position. So really what you have is mechanical energy is going to be a combination of kinetic energy and potential energy. So when you look at roller coasters, the whole thing is mechanical energy. All the going up and down, that's going to be an interplay of kinetic and potential. Let's just kind of look real quick. So fill in the chart. So with a lamp, I'm going to say that a lamp is going to be electrical, transforming into what? What goes in the blank? Radiant. Okay, guitar. I'm going to say that you use kinetic energy to kind of move the string, to strum the string, or to pluck the string, and then that is going to produce a type of sound energy. Ceiling fan. This is a good one. So this is actually going to use electric energy. And then what does the electric energy do? It will create a type of kinetic energy. Okay, now you could argue that the kinetic energy of the fan then creates kinetic energy of air molecules, which is very true. Lawnmower, there's two answers here. Personally, my lawnmower is 100% electric. So for me, mine is going to be just like the ceiling fan. As a matter of fact, it has blades that are just like the ceiling fan blades. Same exact concept. It's just instead of it blowing air, it just moves on top of the grass. They're almost mechanically exactly alike. But some people have gas mowers, and most people have gas mowers, I think. So that's going to actually be chemical energy that you use. And inside the chemical energy, you're going to need some heat to kind of like burn the gasoline to create small, tiny explosions that move it. But the end result is going to be some kinetic energy. Now, guys, we're doing a disservice here because there's actually more than just these involved. There's a lot of energy transformations, but we're just trying to keep it pretty simple. Now, iPhone, this one's really complex. So let's just kind of break this down. So first of all, you use electric energy to charge your phone. That phone, the charge is stored in the battery, which is actually using chemical energy. So a battery is using chemicals to store electricity. Then, as you use the phone, the chemical energy is producing electric energy, which is producing radiant energy, as you can see your screen, and sometimes also produces sound energy as you listen to music. And you could also argue that there's some electromagnetic radiation. So the iPhone is like really complicated, but I think that's enough writing for that block. Just understand there's more going on than what we're talking about right now. All right, so let's just kind of go through this list very quickly. I'm not going to draw a label, but I'm going to let you do that kind of like at the end. Here, I'm going to kind of just let you guys handle that one yourself. But let's go through. Fast-moving river. That is going to be kinetic energy. Now, I would argue that the river has an elevation. That's why, it flows from the high ground to low ground, but that's overly complicated. Swinging a bat, kinetic energy. Pencil on a desk is off the floor, so it's going to be potential. A cheetah running, let's just put a K for kinetic. Energy within a battery. Potential, because remember, the stored energy can become another type. A dam holding back water, potential, because if we open it, then it becomes kinetic. So potential can become another form of energy. Holding a stretched rubber band, that is the elastic potential energy I was talking about, potential. Soccer ball across the field, kinetic. Movement of wind. And by the way, a fan produces wind, and wind is moving air. kinetic. Energy within a slice of pizza. Remember, all the food you eat is stored potential energy in the form of chemical energy that you unleash. So energy within a slice of pizza, potential. Riding a bicycle. So the bicycle's moving, so kinetic. A compressed spring. This again is that elastic potential energy, so we're going to go with potential. We're going to go ahead and go forward here. We're done. Thank you for sticking with me. So just kind of like looking here, I'm going to let you guys do your own thing, but I'm going to just give you some really quick examples. Let's see here. Here is the ground. Here is a ledge. At the very top of the ledge is a massive boulder, and we have a very powerful 8th grade student that is pushing this off the ledge to demonstrate his strength. Strongest kid ever. There he goes. So this is gravitational potential. Remember, the formula here is mass, gravity, height. An alternative formula is weight times height. Elastic potential. Let's say we have a spring. That is a horrible drawing of a spring, but let's say we're pushing that spring down, and then at that point it becomes stored energy. Now, interesting truth here that I want you to realize. It takes energy to store energy. It took energy to get this rock up here. So all energy comes from somewhere. That is the law of conservation of energy. All the energy we have, all the energy that we're perceiving has to come from somewhere, and energy is never lost. It is never created nor destroyed. That's when I said the energy was lost, but then quotation marks, because that's not really what happens. Some energy becomes thermal energy when it goes through a energy transformation. Kinetic energy, let's say the world's greatest soccer player, Messi, kicks a soccer ball, and we all love it when he scores, but that moving soccer ball after he kicks it is going to be kinetic energy. And remember, that formula is 1/2 mass velocity squared. All right, here we go. And last slide right now, we have these last definitions. Guys, these slides that have the different energy forms, these are very important for you guys to know. All right, chemical energy within food is transformed into blank energy to allow a person to move. That is going to be mechanical. I'm just going to put an M here. Mechanical energy is transformed into blank energy when using a noisemaker. We're going to say sound energy. An oven converts electrical energy into blank energy to cook food. I'll put a T here for thermal. Thermal. And I want you guys to write the whole word out. I just don't have enough space with my pen, but you guys need to write the whole word out here. Number 4. Blank energy is transformed into mechanical energy to power a lawnmower. I'm going to go with chemical, although you guys know that my personal lawnmower is electric, and it's a great lawnmower too. I don't think there's any difference really between a chemical or electric. It's just what I personally prefer. Blank energy within the sun is transformed into radiant and thermal energy. Guys, that is going to be nuclear energy, and we're going to talk about this a lot later, but basically inside the sun we go through a process known as nuclear fusion, where atoms are fused together. In nuclear power plants, they go through a process called fission, where they break them apart. So it's a different process, but it's based on the same thing. It's based on the nucleus of an atom. Chemical energy is transformed into blank energy to allow a glow stick to give off light, and that is going to be radiant. Again, write the whole word out. I can fit it here, but it's kind of hard. Okay, and then the last one, blank energy is transformed into mechanical and sound energy when using a blender, and we're going to say that's electrical energy. Electrical energy. So at this time, guys, you have a lot of great information. I know this video is rather long, but the truth is it does prepare you for that quiz. Please, like I said, just look over all the information I've given you today. If there's anything you guys have questions about, please let me know. I would love to see lots of A's, some hundreds. I love it when you guys are successful, so please ask me any questions for any content that you do not understand or does not make sense. Thank you guys so much. Remember to work hard. Make sure your study guide is looking great, and we'll go from there. Thank you so much.